Hi everyone, this video includes the basic problems about laws of chemistry, especially law of conservation of mass and law of constant proportions. Now I'm going to solve the questions that I have solved already in classroom. So some of the questions are missing. I just picked up the ones that are really important. Okay, let's start by telling what is the first law of chemistry. The first law of chemistry is law of conservation of mass. So, what does this law tell us? Mass is always conserved in all chemical and physical changes. Carbon can be burned, it can change into carbon dioxide, or you have some amount of ice and it can melt and turn into liquid. All these changes are chemical and physical changes, and during these changes, if you have, for example, 40 grams of any substance, at the end you have again 40 grams of some another new or the same substance. So you have only one type of reaction that the mass is not conserved. They are nuclear reactions, which can be also called as radioactive reactions, radioactive changes. So let's start with a really easy question. Question number 1. When 2.2 gram of propane, this substance called is propane, is burned completely with 8 gram of oxygen to produce carbon dioxide and water with a formula of H2O here. And when I say oxygen, you're going to understand the oxygen molecule. So if you just write the reaction, it's going to be like this. This is the propane gas. You react it with oxygen to give carbon dioxide and water. Now this is called the skeleton equation. So you see only the reactants. This part is the reactant site, and this part is the product site. So this is a skeleton equation. So if you like to balance this equation, you are not going to start from oxygen because you have oxygen here, 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 and here. So it can be really mixed up. So you can start from carbon, for example. If you have 3 carbon here, you're going to put 3 here. Now you have 8 hydrogens here, you're going to put 4 in front of water so that the hydrogen atoms are equalized. Now comes the number of oxygen atoms. You have 6 oxygen atom here and you have 4 more here, which will give you 10. So by putting 5 in front of oxygen molecule, we'll already balance the number of oxygen atoms. So this is the balanced equation. So let me write that equation again for the next question. Propane plus 5 oxygen giving you 3 carbon dioxide and 4 water molecule. Now it says in the beginning, you have 2.2 grams of propane here. So this is 2.2 grams. And finally you have 6.6 grams of carbon dioxide. This is 6.6. In the question again, it says you have, sorry that the gram is missing here. You have 8 gram of oxygen here. So I put 8 here. So what is missing? The mass of water is missing. So what can you do? You can use a law of conservation of mass. So this means that the sum of the masses of the reactants should be equal to sum of the masses of the products. So by a simple calculation, you're going to find that question mark as 3.6 grams of water. Okay, another question. Now, you see there are some types of experiment occurring between the magnesium here, this is the magnesium, and sulfur here. For example, the first experiment is you have 3 grams of magnesium. You react with a specific amount of sulfur here to produce 4 grams of product. So you can say that these are my reactants where magnesium sulfide is my product. So what is the missing number here? It's going to be 4 because you have 3 plus 4 should be equal to 7. What else? You need to have 35 grams of product, so you have 20 grams of sulfur. So what is the missing number? Is 15 grams here. And what else? You have 12 grams of magnesium here and 16 grams of sulfur. So you end up with 28 grams of product here. Now the second law. Second law is law of constant proportions. Sometimes it is called as law of constant ratio. So ratio and proportion, they are similar words, which means there is a constant ratio by mass between the elements in a compound. For example, let's say that you have CH4 molecule. In this molecule, you have 1 carbon atom and you have 4 hydrogen atom. So the numbers that are given in parentheses like this, they are the relative masses of these atoms. This means that 1 carbon atom is 12 unit gram, where 1 hydrogen atom is 1 unit gram. So if you have 1 carbon atom, this means that you have 12 unit mass of it. So if you have 4 hydrogen atoms, you're going to multiply that 1 by 4 and find out 4 unit gram. So if you just like to calculate their ratio between mass of carbon over mass of hydrogen will be equal to 12 over 4, and if you simplify it, you can find it as 3 over 1. So what is the meaning of 3 over 1 here? If you just make a table of it, you have carbon here, hydrogen here, and the CH4 molecule here. This means for each 3 grams of carbon, you need exactly 1 gram of hydrogen. So how many grams of compound will be produced? 4 grams of compound will be produced. So why this is 4? Because the first law says you should conserve the mass, which means 3 plus 1 should give you 4 here. So in these types of questions, not only you're going to use the law of constant proportions, but you're going to use law of conservation of mass also. Okay, the question number 4. What is the constant ratio between the elements carbon and oxygen in carbon dioxide? In carbon dioxide, you have 1 carbon atom. And at the end of the question, the mass of that carbon atom is given as 12 units here. And you have 2 oxygen atoms. So again, this is given as 16 here, but remember you have 2 oxygen atoms. You should multiply by 2 that number, which will give you 32 units of grams. So mass of carbon over mass of oxygen will be equal to 12 over 32, and this is 3 over 8. So this means that for every 3 gram of carbon atom, you need exactly 8 grams of oxygen, so you can have 11 grams of carbon dioxide. What else? The mass ratio between the magnesium and oxygen is 3 over 2. Of course, this is respectively. Now, please, for these questions, always make a table like I do. You have magnesium here, you have oxygen here, and you have your compound here. Now, this 3 over 2 means for every 3 grams of magnesium, you need 2 grams of oxygen. So you end up with 5 grams of magnesium oxide. So this is the idea for constant mass ratio, to be able to fill this table with the correct data. Now, if you have 8 grams of magnesium oxide, which should be written just exactly here, 8 grams of magnesium oxide. What about the mass of magnesium? What about the mass of oxygen? Now, look at it. How many times does this one increase? 16 times. So these data should be increased also by 16, because this 3 over 2 ratio should not be changed. So you're going to find 48 grams of magnesium and 32 grams of oxygen. So if you like to check yourself, you can check it like, does 48 plus 32 make 80? Yes, so you have already found this 80 grams of product here. Then this means that you had made the correct calculation with the correct math. Another question. When 6 grams of X and 6 grams of Y react with each other to produce some kind of Z, 2 grams of X is excess. Now this excess means unreacted, not involved in the reaction. So again, please make a table. You have X here, you have Y here, and you have the Z compound here. You have some initial values. What were they in the beginning? So you're going to have some reaction values, what are going to be consumed or produced. Then what do you have finally? So this is my table. Initially, I have 6 grams of X, 6 grams of Y. This is before the reaction. Now what happens after the reaction? It says 2 grams of X is excess. So I'm going to write that 2 grams here. So this is left to me after the reaction. So this means that 4 grams of X is used. The meaning of this minus sign is not mathematically, in fact, it is just to indicate that X is used, is consumed here. So if there is no left for Y here, this means that we're going to consume all of it. So how many grams of Z is going to produce? Again, use the law of conservation of mass. This means that you have 10 grams of Z used. So finally you have 10 grams. So if the mass ratio between the X and Y is asked, you're going to look that part only. Not the initial ones, not the final ones, but the used ones. 4 grams of X is used for every 6 grams of Y, so the ratio becomes 2/3. One more question, the last one. The constant mass ratio between the calcium and sulfur is 5/4. And if you have 5 grams of sulfur and 5 grams of calcium, like this, you have the calcium sulfide. Again, you have some initial values, you have some reaction, and you have some final values. Initially, you have 5 grams of calcium, 5 grams of sulfur, and there is no calcium sulfide because this is before the reaction. Now, what is going to happen during the reaction? It says the ratio is 5/4. So you're going to use that ratio for the second line of the table, which means it uses 5 grams of calcium for every 4 grams of sulfur. So 9 grams of calcium sulfide is produced. Finally, there is no calcium left. This is my limiting reagent. So 1 gram of sulfur is left unreactant. So this is my excess reagent. And here is my product, 9 grams of calcium sulfide. So this is the answer for question A. How many grams of which compound is excess? This is 1 gram of sulfur. Now this is answer for B. How many grams of calcium sulfide produced? This is 9 gram of calcium sulfide produced. And finally, show the proof of law of conservation of mass here. Okay, look at the first line. 5 plus 5 will give you how many grams? 10 grams. Now what about finally? 1 plus 9 again will give you 10 grams. So this means that you have done the correct calculation and conserved the mass during the reaction.